the likelihood of the word ham appearing is equal to yes given, sorry, my bad, excuse me. What is the likelihood that the word record is appearing given that the type, or let me use the correct usage that we have, or class is equal to ham. So among all the ham mails, ham SMSs, number of ham SMSs, in how many of those words and how many of those SMSs record was the word record was there? That is what we are doing. Is it making sense? That is the same thing we did when we were doing here, right? What is the likelihood of the color red given like is equal to yes? Meaning amongst all the like toys, which is 55, how many were red in color? So we have looked at those kind of things. So that is exactly what we are having here. All right. That is exactly what we are having here when we are records is equal to yes, male is equal to ham. This is it making sense? There are no records of the word records. It's very confusing. There are no rows where we have the word records when it is ham. Now let me do the other one. What is the likelihood of the word records not being in the sentence given that class is equal to ham? So the answer is this. Among all the mails or SMSs where ham existed, how many did not have the word ham, did not have the word record? All the ham SMSs did not have the word record. Is it making sense? That is why it is 1. Let me make it even clearer. Use a different color. What is the likelihood of the record word being in the mail given that it is spam? So record word existed, but it belongs to spam. It is this value. All right. Like this, we are having it for 1230 such values. This is my classifier. Is it clear, friends? All right. So we'll have a 4-minute break, 5-minute break. All right. We'll have a 5-minute break. So because I wanted to finish that topic, that is why I took that. It is or we'll have a break till only, all right, just 3 minutes. All right, so we'll proceed. Backend team, can you please share the attendance link? Backend team, please share the attendance link. Please give your attendance. The attendance will get expired in about 4 minutes. Right? The attendance link will expire in about 4 minutes. Please give the attendance. And I would also like to see how many people leave after the attendance. That's okay. That's a risk I'm willing to take. All right. So while you are giving your attendance, I'll just go ahead with the class. It will anyway expire in about few minutes. Backend team, please do not share the attendance again. All right. So I have frozen the chat options till the attendance is over. All right. I have frozen the chat options till the attendance is over. No one can chat. All right. Now, once we have established these values, ultimately the likelihood measures that we have established for all the 1230 values, that is what is the SMS underscore classifier. So now the SMS underscore classifier, what we have seen here is nothing but the learning process. All right, what the model has learned. Now let us subject this model to the test. Now here I am directly giving the section 2 exam. I am not giving the section 1 exam. I'm directly giving the section 2 exam. And when I do this, the SMS underscore classifier with the likelihood measures and the prior probabilities, of course, is already known, is performing it for the test value, which is 1390 values. It is now checking those values and, doing it. All right. So it'll take some time. That's okay. It is done. All right, it is done. Now, SMS underscore test underscore PRED is going to be the values. Now, basically, if you go back to the this thing, so I have the section 2. I have the section 2 question answer by student. Answer key. So true, true, false, true, false, 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 true, false, false. So if you look at this, what do we have here? We have a mismatch here and we have a mismatch here. So out of these questions, the student has given 3 out of 5 correct answers. All right, has given 3 out of 5 correct answers. That is what I am now going to find out by creating what is known as a cross tabulation. So I'm going to create SMS underscore test underscore PRED, which is the output of the exam. SMS underscore classifier is the exam that was given to the SMS underscore test data, and this is the output. I am comparing that with SMS underscore raw underscore test dollar type, which is nothing but the answer key, the actual answers. So when I the proportion dot chi-square to this thing, just these are just values that are given there. So when I execute this, oh my bad. So it says could not find cross table because this particular package G models is something that I have not yet loaded. So G models, I load this particular package, and then when I execute the cross tabulation, you look at this, the correct answers all right. 1202 and 152 are the correct answers. What are the incorrect answers? So there are 31 cases where the actual SMS was spam, but my model has wrongly predicted as ham because the prediction is here. And this is the actual. All right. So it was actually spam, but my model has wrongly predicted as ham. Here there are 5 cases where it was actually ham, but my model has wrongly predicted as spam. So the error is 31 plus 5 out of 1390, or the accuracy is 1202 plus 152 divided by 1390. This is the accuracy. So let us now check. This particular function is, you see this double equal to. Now double equal to stands for the scenario where the values matching. Now if you see here, this function, if you were SMS underscore test underscore PRED double equal to SMS underscore type, the answer for this data that I have here will be 3. How many instances were they equal? Now remember, the double equal to is a comparative operator. You are trying to compare whether they are equal or not. All right, whether they are equal or not. In certain cases, we are going to compare. All right, in certain cases, we are going to compare. We are going to compare if they're equal or not. If you are going to put only a single equal to, it is an assignment operator. I'll give you an example. If I say A is equal to B, then if B is equal to 3, then A is equal to 3. Do you understand? Let us say I have assigned B is equal to 3, then I say A is equal to B, then A takes the value 3. But if B is equal to 3 and A is equal to 5, if I say A double equal to B, the answer will be false. No, A is not equal to B. Do you understand the concept of double equal to, which is a comparative operator, and a single equal to is a assignment operator? All right. Okay. All right. So that is what we have learned now. And now this is the outcome. Now, if you want to also check the same model, now here I'm going to give section 1. I have the test paper. I'm now giving this section 1. Let me see how it is performing. All right. Before that, I have not done this thing. So test accuracy, it says 97.41%. So in section 2, the person has performed very well. Let us see section 1. It will take some time to operate. All right. Now it is taking some time. Let it take some time. Friends, it was for 10 minutes. I mentioned 4 minutes, but I didn't realize it was for 10 minutes. All right. The attendance link expired exactly at 7:20. That is 1 minute back, it has expired. Okay. The attendance link has only expired 1 minute back. While I wait for this, I just want you to know. Enable what? No, it is not in my hands. It is not in my hands to enable it. I'm sorry, I'll not be able to address questions that are not as part of the topic because we have so many things. We have so many people who are part of this. There are people who are talking about some advanced things. All right. So I'll not be able to address that particular aspect at this point of time. Okay. And yeah. Yes, the attendance is over. Okay. This is also done. Let me just start. Okay. So now let us look at the training accuracy. All right. And if you look at the training accuracy, 98%. So slightly more, but obviously my model has not memorized. This goes without saying that my model has not memorized. It has only learned it properly. And this is how the thing is done. All right. So let us now do the same thing in Python as well. Okay. Let it open. Yeah, it is open now. All right. So let me now go ahead and load the ham spam Python code into it. All right. So when I load this, this is what I have. All right. Now, so now we are going ahead with this data set. So we have the pandas, the NumPy, and we are going to be taking what is known as the count vectorizer TF-IDF transformer. All right. You all know about the TF-IDF, term frequency inverse document frequency, that we have learned as part of the text mining. All right. And now I'm going to load the same data that we've already worked with. All right. The same data that we have already worked with. And for this, I need a package called RE, which is regular expressions. Okay. And I'm going to create a null entity called stop words. All right. Unlike R, where it is relatively easy, here I'm going to create a null entity called stop words, and I have the stop words value text file also. So I'm going to now load these stop words using this format. This again is a command that you are aware of, so that it comes into one single block. This entire thing is one single data point. All right. Now I'm going to split the stop words on the basis of a new line. So I now have 575 stop words. All right. And I'm going to perform the cleansing operation. So basically this entire thing, let me just show it in one screen. So if you look at this, I have created a text cleansing what do you call function, user defined function. All right. A text cleansing user defined function, which starts from putting everything to lowercase, removing all the numbers. All right. And then creating an intermediate entity called W, which is a blank entity. Within that, I'm going to pull the words which are having length more than 3. So yes is going to go out. BYE, by, is going to go out. OK is going to go out. All right. WELL is going to remain. All right. So like this, I'm going to take only words that are 3 letters or more. So that is what I'm going to do. So I'm creating this particular function, and I am finally joining those things into a particular single word. All right. I'm joining all those things. First I've split it and I join it. Now I'm going to apply this particular text underscore, sorry, cleaning underscore text, which is the function. I'm going to apply this to this particular line. Hope you are having a good week, full stop, just checking in. Now H capital, U 3-letter words, R 3-letter words, A 1-letter word, full stop, J capital, in 2-letter word. Now when I execute this particular command, please look into the console window and you will see hope is small case, having is there, UR is being removed, good is there, A is removed, weak is there, full stop is removed, J becomes small, checking is there, in is removed. All right. Similarly, hi, hope I can understand you are feeling 1221, 1231. Hi, how dash dash dot dot are you? So execute this and hope understand your feeling. Everything else has been removed. Hope understand your feeling. Everything else has been removed because everything else is either 3-letter or numeric, etc. All right. So this is what it is. Now I'm going to apply this text cleaning. This is what was some samples I wanted to show you. Now I'm going to apply this text cleaning to the email data text. All right. I'm going to apply it. So when I get it, now email data dot text has all been cleaned. So email data text, if you look at this, give back thanks, also doing only have, complimentary star, this much buzzy, so on and so forth. All right. And finally, I'm going to remove the empty rows. Now, in the process of doing this, there may be certain SMSs that may just be O, OK, C, SEEYA. All right. So if there is an SMS which is this entire thing will be removed. It will become a blank entity. So I am now going to remove all those rows. So I have 55559. When I do that, incidentally, there are no such rows that are empty, but I have to do this particular exercise. All right. Then I'm going to remove the train test split. All right. Because what we are doing right now is machine learning supervised. All right. The topic that we are doing is machine learning supervised or data mining supervised. All right. In that, we obviously have to do the train and test split. Only then this will work. So I'm going to load the train test split option from sklearn.model.selection. Now I am going to split the email hyphen data test size is equal to 0.2, meaning I'm going to split the data into 80-20 split. All right, I'm going to split the data into 80-20 split randomly. All right, 80-20 split randomly, and all right, randomly I'm going to split it, and the 80% is going to email underscore train, 20% is going to email underscore test. So when I execute this, you can see here two objects have been created, email underscore train and email underscore test. So 4447 is the 80% and 1112 is the 20%. All right. Now when we have done it, we are now going to create a matrix wherein we are going to split the words. All right. And also create the counts. And I am going to use the count vectorizer to split the words. All right. And also create a kind of matrix. All right. So this is what emails underscore BOW stands for, emails underscore bag of words. All right. Now emails underscore bag of words transform the data because we have already created this function here. This function is the count vectorizer function. Now when I'm going to transform this, I get all email matrix. All right. And this all emails underscore bow, I'm going to do it for the test data and for the, train data and test data both. I'm doing the transformation. All right. Test emails underscore matrix, I have done the transformation. And finally, doing the term frequency, inverse document frequency, the whole objective is basically to get it in zeros and ones kind of a scenario. All right. We have done that. And then, sorry, this command, my bad. This command here is the function that I'm creating, and this is where I'm applying this function to the train data. All right, and if you look at the shape of the train data, it is 4447, 6661. So there are 6661 expressions. There, the approach we had taken in R was that we are only taking words that are greater than, that are appearing more than 5 times in the data set. We are removing the words that are appearing 4 times or less. Here we are taking all the words, all right, to make it slightly better. Okay, but we are taking only 4-digit and above word. All right, we're only taking the 4-digit and above word. Now, when I do the same thing for the test also, I'm doing the transformation for the test. If you look at the shape, it is 1112661. These are the so many words that we have. All right. Now, finally, we are loading something called as naive Bayes, multinomial naive Bayes. All right. We are loading this multinomial naive Bayes, and I am defining classifier underscore MB as the MB. Now, MB is something I have already loaded. I'm defining another object called classifier underscore MB. And on that classifier underscore MB, I am running the train TF-IDF, the train input was with the train output. So the classifier model is complete. All right. Now we are going to use the classifier underscore MB, which is the object or the exam, whatever you call it, on the test TF-IDF, which is nothing but the section 2. Remember section 2? I just discussed. So on the section 2, and then you do the accuracy of the model is 95.77. All right. If you want to know a little bit more, there is something called as sklearn.metrics import accuracy underscore score. All right. And then the accuracy score is the same thing. I mean, if you want, you can use this particular command, or you can use the np.mean and put the double equal to, that is the assignment thing. All right. Or you can also create the cross tabulation. All right. You can also create the cross tabulation. And you have the cross tabulation 964, 101, 46 and 1 is the error. Now let us do the same thing for the train underscore TF-IDF, that is section 1. We are running the exam for the section 1 accuracy. Look at the accuracy. It will take some time because it's definitely larger. Once it is done, we will check it out. It's taking a lot of time. Let me just wait. I don't know why it is taking so much time. Let me just stop it and I'll execute it again. So there was some issue with that. Let me attempt to do it again. All right, let me run this classifier once again. If it doesn't, this time it has run very fast. All right, it has done. Now let me execute the accuracy and I get 97. So I have got 95%. If you remember here, I got 95% accuracy for the section 2. I will always call it section 2 because it is easier to remember. All right, 95% accuracy for section 2 and 97% accuracy for section 1. So by and large, it is a good model. The accuracy is also pretty good. The model has learned very well. All right. So that is what we have here. Okay. All right. So let me just quickly skim through certain questions if there are, because I wasn't looking at the message. I'll only be looking at the questions relevant to this particular topic. I'll not be talking about other things. I don't have. If the data is continuous, we assume that it follows Gaussian, then likelihood of particular will be zero. How can we find that? So that's a interesting question. Obviously, it is not currently as part of our this thing, but I'll quickly address that. If it is Gaussian, then there is a tuning parameter which will take the values to near zero. Now, this is people who are not able to understand. It's perfectly all right. The Bayesian classifier can also work for continuous outputs. All right. So if it is continuous, then it will follow. So right now we have done the multinomial Gaussian. We'll have the multinomial naive Bayes. We'll have the Gaussian naive Bayes. So wherever their likelihood values are zero, they'll be replaced with near zero values. All right, they'll be replaced with near zero values, and that is what it is. These I have so many messages, but there are nothing related to our neural networks. Our neural network are used while training in background. No, this does not involve neural network. This is a Bayesian classifier. There are neural networks also, but this is not using neural networks. Okay. Now we use confusion matrix. I have not revealed the name confusion matrix, but we'll be discussing about the name confusion matrix subsequently. Okay. And again, there are so many things that are there, but nothing related to. Somebody asked me about the chi-square test. I'm sorry, but we will not be able to discuss about the chi-square test in this particular forum. So that I will not be saying. Training and testing is done only in this is ML, but you're explaining in data science. This is within data science. This is ML. We are doing machine learning supervised. As of yesterday, we started doing machine learning supervised, also called as data mining supervised. All right, that is what we done. Again, all junk messages that is not related to other things. Spider is one of the things that we use for working on Python. You can work on anything. You can work on Jupyter notebooks. You can work on shell Python. There are quite a few things that are there. You can work on any of them. All right. So I have learned it on Spider. I'm continuing with Spider. Spider is also pretty convenient. So that is why I'm using that. Is there any other library important? There are more than thousands of libraries available in Python. No single human being can know about the library, and therefore we live in the time of internet. So if there is anything, so I'll give you certain websites: Stack Exchange, RBlogger, Experts Exchange. These are some websites where you can have forums. If you are a hardcore programmer, then you may want to discuss about all those things. Please tell yes or no, can we use Pearson correlation on numeric data, which is categorical? Yes, you can use Pearson's correlation. Yes, you can. All right. I think both of them have their, this thing. But if you really want purely visualization, all right, if you want to look at only the visualization and very rich visualization, then neither R and Python. You go for some business intelligence tools like Tableau. Tableau is a program that we offer. All right, that's a separate program. We offer Tableau training program. All right, so that is even richer, even better. That is what we have there. All right. So with this, let me just go back to the presentation here. All right. So we have now completed the concept of probability, joint probability, conditional probability, learn about the Bayes Runets application, learned about the posterior probability. So these are the things that we have learned. Any questions related to naive Bayes? Any questions related to knife base? Now you see, that is the whole tragedy of this. We had reached 181 just before the attendance. Yesterday we were only 173. All right. Today we had reached 181 before the attendance, and now the session is not over and it is only 141. So, okay, very interesting question. I will post this question for everybody to see. Let me start the recording once again. I will post this question for everybody to see. Let me just copy it. And 1 minute. Why is it not pasting? Okay, I'll read out the question. Knife base assumes that all features are independent, but in real life it is not possible. Then how can this give correct results? And what are advantages and disadvantages of knife base? Because the Bayesian classifier assumes independence, that is a shortcoming. All right, that is a shortcoming of the Bayesian classifier. Therefore, in real life, we do not use only a single classifier model. We use multiple models to check for the accuracy. Point number one. Point number two, if the problem of independence, or rather I shouldn't say problem of independence, if the problem of the assumption of independence was going to affect our model, we would not have got 97% train accuracy and let me just show the test accuracy. All right, we wouldn't have got 97% train accuracy and 95 or 96%. Basically, it is 96, right? 95.77 is 96% test accuracy. If our assumption or the problem of independence was there, this wouldn't have happened. Now, therefore, in our data, in this particular data, the values or the alphabets, I'm sorry, not alphabets, the words, the usage of the words is independent. Unlike the example that we discussed with reference to the spam and ham, it is unlike the example of spam and ham that we discussed, this is going to be not having a problem. Spam and ham, definitely, if you try to do that with reference to the word of the lottery word, that was I was thinking, what was the word? The lottery word, there definitely the independence problem would have created a major problem in the accuracy. All right, so that is one aspect of it. Next question, can you tell data prior? Why you are having doubt about data prior? All right, let me just show you the data prior. All right, so class prior, data prior or data prior marginal is nothing but the probability associated with the data type or the class. Now, for instance, we were looking at the word records. Now, this particular, whatever likelihood measure we did, all right, we did the likelihood measure of what is the likelihood of record is equal to yes given class is equal to ham, one scenario. Similarly, record is equal to yes given class is equal to spam. Then likelihood of record is equal to no given class is equal to ham, and then likelihood of record is equal to no given class is equal to spam. These are the four things. Now, all these four values will only make sense on the basis of total. In total, how many times the word records has been used. So therefore, that is a ratio that I have to bring in For a certain case, I may have that particular value to be very high. All right. I may have that particular value to be very high, but that particular value may be very high. Let us say the likelihood measure may be very high because the existence of that particular data prior is also pretty high. All right. Is it clear, friends? So that is why we also have to look into the data prior measure as well. All right. That is a very, very strange question you have asked. Statistics is most important in data science. It is the most important thing in data science. You cannot do without statistics. All right. So the more you know about statistics, the more stronger you become, the better you become. All right. It is very, very important. All right. So we will just go back to our presentation and just get introduced to the next topic, which is again pretty easy. So we are again continuing the machine learning. All right. First we did machine learning classifier naive Bayes. Now we are doing machine learning classifier k nearest neighbor. All right. We are doing the k nearest neighbor. This is the topic that we'll be taking up in the next class. So do I take it that there are no further questions? All right. So I see that there is one gentleman called Venu Babu who has tried to enter at least some 100 times. And I don't know, he's not managing to enter. Something is wrong with him. I really don't know. He comes in and he gets out. And again, he comes in and he gets out. He's been desperately trying. Okay, it is all the internet connectivity at your end. So I can only, keep allowing you to come. Okay. Yeah. So what I used to recommend to the other people when we used to take classes and people used to connect from remote locations using mobile data, I would tell them, see, you are having mobile data, you are having geo connection. During the day, you will exhaust the day limit. You will watch videos, you will watch movies, all that will be gone. Then when the class is going on, you will say, sir, no data. Right? 1.5 GB per day is what is available. That is more than enough to attend a 2-hour session. But then you must save it. Right? You must save it. You must keep your data turned off for the entire day and then save it. So you should be judicious in the usage. It is not unlimited. All right. I cannot be held responsible for. Yeah, I realize there are people who are connecting from remote places who do not. That is the kind of sincerity we are looking for. Who do not turn on their data the entire day, and keep the data turned off. They only turn it off during the class so that they can uninterruptedly have it. All right. So that is something that is really appreciable. Okay. So now let me just address some more questions because we are running close to time. I don't want to start a new topic. So any suggestions to become a statistician? Why do you want to become a statistician? Learn statistics. Don't. All right. Learn a lot of statistics. Try to watch our YouTube channel. There are so many statistical topics that are conducted there. All right. You can look at that. There are a lot of online forums where you can simply register and they will give you a lot of quizzes and tests. On the record, I'm not able to. Off the record, I'm not able to remember these things that are there. But yeah, we have those things available as well. Yeah. Yes, we do have online classes in the morning from 7 a.m. to 9 a.m. A batch has just started, and you can probably, want to talk to your respective sales coordinators or visit our website and, discuss about those things. Okay. Yeah. Team, can you stop YouTube live? Because I think I'll just wait